TCP connection setup for F5 BIG-IP LTM virtual server means full proxy architecture. Full proxy. So full proxy, I hope you understand. Full proxy means there are two separate layer 4 connections or TCP connections, one between client and F5 BIG-IP LTM here, and another connection between F5 BIG-IP LTM and the backend server, right? So two separate TCP connections. TCP connection. And obviously full proxy means request and reply, they both like go through the F5 BIG-IP LTM system. It's not like request is coming via F5 BIG-IP LTM and reply directly is returned to the client. That's something like direct server return or maybe a half proxy kind of thing. So that's very different concept. But in full proxy, what happens? Request and response, that is reply, both like pass through the F5 BIG-IP system. And full proxy means like complete independent layer 4 connections, TCP connections, one between client and F5 and the between F5 and backend server. But now, the point that we want to understand here in this section is whether TCP connection behavior would be packet by packet. And what do I mean by packet TCP connection behavior? So packet by packet means initial SYN request is sent from the client to the F5 BIG-IP LTM virtual server, and then F5 BIG-IP LTM system makes the load balancing decision and passes the SYN request to the pool member, like the SYN packet, right? SYN here, and then SYN packet sent to the pool member, then SYN ACK, and then again SYN ACK, then ACK and ACK, like this. That's something like packet by packet TCP behavior. Or like there would be like complete three like TCP messages like between client and F5 BIG-IP LTM. Means like three-way handshake occurs on the client side of the connection before the F5 BIG-IP system initiate the TCP handshake on the server side of the connection, right? Because that's on the way. Like I mean, like complete three-way handshake here, TCP SYN, SYN ACK, ACK, and then here TCP SYN, SYN ACK, and ACK. Or even after three-way handshake, like three-way connection, F5 BIG-IP LTM still doesn't send like TCP SYN to the backend server. F5 BIG-IP waits for the first data packet to arrive, like HTTP GET request, right? And then after TCP three-way handshake with backend server. That's another way of like setting up TCP connection. So in this section, we are going to understand like the same, like I mean like the TCP connection setup, right? In full proxy architecture, obviously. Full proxy architecture is different than the packet-based design. I'm sure you know like what is packet-based design, but let's have very quickly a recap of like packet-based design. So in packet-based design, what happens? Like device sitting in the middle of communication stream, what it does, removes layer 2 header, perform routing, adds layer 2 header, and then send to the destination or maybe to the next group device, right? Means device is sitting in the middle of communication stream, but device is not the connection termination point. So if client here and maybe the web server or HTTP server clients wants to communicate with the web server HTTP, and we understand like HTTP means like on top of TCP. So first three-way handshake, TCP three-way connection, and then on top of that HTTP messages are exchanged, right? So first TCP three-way handshake, and once TCP connection is established, then on top of that HTTP messages are exchanged. So what happens here in the packet-based design? In packet-based design, client sends like the first packet. Let me erase this. Client sends first packet, that is TCP SYN packet. And let's say client IP address is 10.0.0.1 and server IP address is 172.16.0.1 and 10.0.0.100 is the gateway address. So this TCP SYN packet means IP header, TCP header, and encapsulated inside Ethernet header, layer 2 header, Ethernet header, and here frame check sequence, right? So Ethernet header means like source MAC, destination MAC, and ether type field. Okay, so these three attributes are parameters. So what router or gateway does here, first, like after performing error checking like CRC and the stiller, it opens the Ethernet header, layer 2 header, and check the MAC address, like what is the destination MAC address here, right? Destination MAC address. And if router finds its own MAC address at the destination MAC, okay, so what it does, it extracts packet from the data frame. This packet is taken out of data frame, right? And now router will look at the layer 3 header, IP header, right? IP header, this one. What is source IP address? 10.0.0.1. What is destination IP address? 172.16.0.1. So now router understand like destination IP address is not my IP address, right? So I should not look like deeper inside it. I should not open the TCP header because packet is not for me. I'm just the gateway. I'm just the middleman. I'm just to route the packet to the destination. So what router does here, router will check the routing table. Do I have the matching route table in my routing table? Is there any route for the destination IP? And if router finds any matching route in the routing table, then packet is switched between the interfaces. Packet moved like from ingress to egress interface. And then again, layer 2 header is added to the original packet, right? And I assume like there is no NAT and other configuration on the device, so obviously source or destination IP address remain intact, like will not be changed or translated. And layer 2 header is again added and error checking, like, and then sent to the next hop or maybe to the destination IP address. So that's what packet-based design is. So in packet-based design, client is allowed to communicate directly with the server with the help of a gateway, the middleman, like the middle device sitting in the middle of communication stream. But it's very different than the proxy, because in F5 BIG-IP, what happens? Client always initiate connection to virtual server IP address, right? Client is not allowed to communicate directly with the server. Means LTM itself is like pretending as it is a server. It is telling everyone that I'm the web server. Yes, you can talk to me, right? But it's not a web server. We all know that. Okay. So here, like the scenario is completely different in full proxy architecture or proxy environment. Client and server, they never communicate directly with each other. There is a middleman, and the middleman is something like where connection would get terminated. So client connection would get terminated here. But the point that we want to understand here, like, is something the connection behavior, right? Like whether complete three-way handshake between F5 and client, and then three-way handshake backend side, or maybe like packet by packet. So that's what we are going to understand in this section. So let me clear the screen first, and then I'm going to discuss first about the standard virtual server type. So TCP connection behavior in standard virtual server type. And also I'm going to show you like how it is created, and a different profile that is associated, and obviously the connection behavior, right? So if I start with the first, that is standard virtual server. And standard is the default virtual server type. So whenever we create virtual server in F5 BIG-IP LTM from the web UI, so the default virtual server type is standard, right? You must have noticed like at the time of creating virtual server. And by default, a layer 4 profile for HTTP like TCP profile, layer 4 profile is by default attached with the standard virtual server layer 4 profile, right? First thing, profiles are used to modify traffic processing behavior. Okay, it's just a quick recap. In fact, profile, so profiles means traffic processing behavior are changed here because a standard virtual server with a layer 4 profile means now load balancer is your basically a network load balancer, technically network load balancer. And why like a network load balancer? Because now F5 big IP system will examine data like found in IP header and TCP or layer 4 header. No screening above layer 4, right? No screening above layer 4 up to layer 4 of OSI model. A network load balancer means like we won't be able to uh, use some layer 7 functionality here like the I rule or some other, like even the ASM policy and some other configuration. Means your load balancer is what is for that specific virtual server. Load balancer would operate up to layer 4 of OSI model, because in F5 big IP LTM, whenever you buy a purchase a F5 big IP LTM, either physical or virtual appliance, so you are not going to tell F5 big IP that I need a layer 4 load balancer, like the network load balancer, or I need a application load balancer or gateway load balancer. No, right? It's all about the configuration. So if only a layer 4 profile is associated attached with the virtual server, means like for that specific virtual server, load balancer will operate up to layer 4 of OSI model, very much like a network load balancer, right? And if we attach a layer 7 profile with standard virtual server like the HTTP profile, for example, means now data would be examined up to layer 7 of OSI model. Means IP header, TCP header, and as well as HTTP header. Means your load balancer for that specific virtual server would be what? Application load balancer. Correct? Application load balancer. Right? If you have ever like worked in any cloud computing environment, I mean like Microsoft Azure or AWS. So whenever we just create load balancer there, so generally we are given like option to select like from the list like whether we want to spin up or launch network load balancer, application load balancer, or gateway load balancer, right? But the same is not true here for F5 big IP system. No, F5 big IP system itself, right? The device itself is neither a network or application. No, like it has capability to operate up to layer 7 of OSI model. It's all about the configuration, right? Understood? Means if there is layer 7 profile associated with the virtual server, so for that specific virtual server, load balancer would operate up to layer 7 of OSI model. We can use all layer 7 features, functionality, iRules, cookie based persistence profile, ASM policy, application security policy, right? All layer 7 functionality, very much like net application load balancer. And why I'm discussing this layer 7 profile here in this section? Because when we create a standard virtual server, and if we do not attach layer 7 profile with it, so what happens? Like the TCP connection behavior, like I want to discuss like here the TCP connection behavior. So a standard virtual server, no layer 7 profile. Okay, so connection behavior is here means a standard virtual server only with layer 4 profile, and layer 4 profile is by default attached with the standard virtual server. So what happens here? The three-way TCP handshake, right, between client and F5 BIG-IP system occurs first, means three-way handshake like between client and F5 BIG-IP system. This way TCP SYN ACK, and then ACK successfully established three-way handshake, and then F5 BIG-IP LTM makes the load balancing decision, selects a pool like member from the pool, right, and initiate the TCP handshake on the server side of the connection. So maybe with server 3, 2, 1, so TCP connection here means like the SYN packet, and then SYN ACK, and then again acknowledgement. It means first like TCP three-way handshake between client and F5 BIG-IP system, and then another TCP three-way handshake between F5 and the backend server, right? I'm going to show you this like just so I'm just opening here F5 BIG-IP LTM. Okay, and there is one virtual server already created here, HTTP virtual server, and associated with a pool. So what I'm going to do, I'm going to disable pool members. So already two are disabled. I'm going to disable third one also. So there is a virtual server, but pool has no active members. And you understand the flow, traffic processing, I mean like the packet flow here in F5 BIG-IP LTM. So what happens, like the client request hits like virtual server. If virtual server has a default pool associated, then forward it to default pool, and pool means logical grouping of servers or members. So here if like there are 3 members, so member is selected with the help of load balancing method configured per pool basis. Even load balancer itself doesn't have any load balancing method. You understand that, right? Load balancing method is configured where? Per pool basis. Okay. So if there are 2 different pools, so they both can have different load balancing method configured. So client request hits virtual server pool, and then there are 3 members. So member is like chosen from the load balancing method configured per pool basis, and then like client request is directed to that pool member. Now here all 3 members are disabled, means pool is also disabled, unavailable. As long there is only one even active member, means like pool status would be showing there as available. But since all 3 members are down, unavailable, disabled, means pool is also disabled. Now what would happen now? If I try to access this virtual server, if I try to access virtual server from the client, here is the client and F5 BIG-IP LTM system, there are 3 servers in a pool, all 3 servers disable client machine. So if I try to access like the server with the virtual server IP, that is virtual IP address, so what happened here? First request TCP SYN, yes, like hit the virtual server IP, F5 BIG-IP LTM virtual server would reply with the SYN ACK, and then again ACK three-way handshake, and then what? Reset. Why? Because there is no active member. Okay, there's no active member. Means if we like open here Wireshark, let me open that, and what is virtual server IP? So see the status here, gone, and virtual server IP is 172.16.1.201. So I'm going to access this virtual server, but before that, let me start capturing packet. And use the filter here. Okay. Capture, start, filter used, minimize this. And now I'm going to access 172.16.1.201. Obviously, I'm not expecting any reply here. Site cannot be reached. Yes, I was expecting same error message. And let me stop the capture. Look at this. So source IP 1.9 and destination IP 201. So first packets in SYNAC, and then after you see here like a lot of reset messages here. Means three-way handshake between client, three-way handshake between client and delete this F5 BIG-IP system. First three-way handshake successful. But what about the backend? Like I mean, like the TCP three-way handshake with the pool member, not successful because there is no active member here. So here, like the first TCP SYN ACK, but since all like members are down, so immediately a reset, a TCP reset, right? What if, and the virtual server here is what? Standard. If I just double click this virtual server, so virtual server type is what? Standard, default. This is the default virtual server type. And what about profile? So profile is only layer 4 profile. Is there any layer 7 profile associated with it? No, right? And that is why only three-way handshake and then reset. Okay, what if I also attach a layer 7 profile with it? Let me quickly update this, update it, and start again, refresh this page, refreshed, back to this, and see here, stop. So TCP SYN ACK, and then HTTP request, and again like TCP reset message, right? TCP reset message again, like SYN ACK three-way handshake, and then get request and then reset. This is the reset message, and from where this reset packet is coming from? Virtual server IP address. And you just see here, like look at the structure here. There is no layer 7 data in it, right? Because you understand like TCP behavior. So if here like there is a client and server, even in client and server, or maybe any device in the middle. So what happens? First, TCP message, TCP SYN. So even TCP SYN means what? IP and TCP header. No data here. So TCP SYN ACK. Once TCP connection is successfully established, so on top of that, HTTP messages are exchanged. So once like TCP successful done connection, and then HTTP request or HTTP get request means what? Means IP, TCP, and then HTTP data. And you understand like TCP means like only layer 3 and layer 4. And you can do the verification from here also, layer 3 and layer 4. No layer 7 data here. And that is why devices, even the firewalls or SD-WAN devices sitting here in the middle of communication stream, generally they won't be able to identify application from like the first packet, or maybe the second, or maybe the third. So once TCP connection is successfully established, then the fourth packet, that is the first any packet, I mean like HTTP get or any other request, then properly applications are identified, right? Because initially, even the firewall, what firewall can do? Firewall can control traffic based on IPs and ports only, and you understand the reason. Because if there is no layer 7 data in it, so of course like cannot be identified. However, like nowadays, like there are a lot of devices and they have some advanced mechanism that even like the SD-WAN devices, right? Like Silver Peak, even 4DNet, or like they have like like first packet identification mechanism. First packet identification. So I don't want to get into like that discussion because that is out of context. But yes, like only layer 3 and layer 4, no layer 7 here. Obviously, we are not Even we were not expecting that. So is the connection behavior here, right? It means if there is a virtual server, a standard virtual server with layer 7 profile, then the connection behavior is different. Means a standard virtual server with both TCP means layer 4 and layer 7 profile. Layer 7 profile and layer 4 profile. Both. So TCP is your layer 4 profile and HTTP means layer 7 profile. And not only the connection behavior is different here, because the connection behavior is what? Now, first packet TCP SYN between client and F5, and then SYN ACK, third packet acknowledgement. Still, no TCP connection with any pool member. F5 BIG-IP LTM waits for first data packet to reach, to arrive, right? Now, client sends on top of it, like TCP connection, HTTP GET request data packet, right? Now, F5 BIG-IP LTM makes like a TCP connection with the packet server, right? So after three-way handshake, BIG-IP LTM waits for a data packet from the client before selecting a pool member and negotiating, I mean, like the TCP connection. So it's very good, like, right? Because at least even in case if like you have also created and attached ASM policy with the virtual server. So in case if the HTTP request has not been found valid, I mean like the legal means let's say HTTP request is illegal, so immediately dropped here, right? So obviously it depends like whether you have also created and attached ASM policy or not, but it's a good feature. I mean like just waiting for a data packet from the client before selecting and like establishing TCP connection with the pool member, a very good feature. So with layer 7 profile, not only the TCP connection is going to be different, plus now your F5 BIG-IP LTM for that specific virtual server will examine data found in layer 7 header also, means operating up to layer 7 of OSI model. So we have very much changed the traffic processing behavior. Traffic processing behavior has been also changed now. Your load balancer for that specific virtual server is what? Layer 7 load balancer, right? So now you can have ASM policy attached. You can have like I rule created based on some HTTP attributes, or maybe cookie persistence profile, right? And some other advanced like layer 7 features like fallback host, and there are like many more in fact. Okay, so layer 7 profile means layer 7 load balancer, proper application load balancer now. Okay, but a standard virtual server without layer 7 profile means what? A network load balancer only, operating up to layer 4 only. So load balancer device itself doesn't have any load balancing method, doesn't have like something layer 4, layer 7 and all that. No, it's all about configuration, it's all about the profiles. Profiles are very important in F5 BIG-IP LTM, right? So a standard virtual server means without layer 7 profile, first layer 4 connection between client and F5 BIG-IP LTM, then another layer 4 connection between LTM and backend server, right? And even though like there is a full proxy architecture, two separate layer 4 connections, but you understand whenever F5 BIG-IP LTM initiate TCP connection with the chosen like member backend server, then the source IP and source port both remain unchanged, intact. So by default, client IP address, source IP I mean, and the source port both are not changed. Only the destination IP address is translated here. So proxy not means like by default LTM will be using its own like floating or self IP address while communicating with the backend member. No, right? That not happens by default. You understand that? Okay, so a standard virtual server with layer 4 profile only, like first like TCP connection between client and F5 BIG-IP system, then between F5 and the backend server, and the same like a standard virtual server but with both layer 7 profile also, three-way handshake here, and then first data packet, after that TCP connection with the backend server, right? Let me talk about another important virtual server, and another virtual server is performance virtual server, performance layer 4, performance layer 4 virtual server, layer 4 virtual server. So when we create performance layer 4 virtual server, so by default here fast L4 profile, fast L4 profile is attached with the performance layer 4 virtual server, and the connection behavior here is different, right? The connection behavior here is packet by packet, packet by packet TCP behavior. And what do I mean by packet TCP behavior? So packet by packet means the initial SYN request is sent from client to the BIG-IP LTM, this one. So initial SYN request is sent from the client to the BIG-IP LTM virtual server, and then BIG-IP LTM system makes the load balancing decision and passes SYN request to the pool member, maybe this one, pool member 1 or pool member 2, right? SYN request again here. So LTM sends SYN request to the node, a member, and this node sends SYN packet back to LTM, and then LTM to like this client, SYN third packet again from client to F5 BIG-IP LTM, and then here again the third packet acknowledgement, right? So that's what packet by packet TCP behavior is, packet by packet, where in which virtual server type? Performance layer 4 virtual server. Let me quickly jump to this configuration page of F5 BIG-IP LTM. So, and here in here I'm going to change virtual server type from standard to performance layer 4, right? And look at the profile here. Profile is what? Layer 4 fast L4 profile. Okay, fast L4 profile. Let me update. So updated. So this time virtual server type is performance layer 4, means packet by packet TCP behavior. All right. So let me start the capture here. It started already, and refresh this page. Okay. No, obviously response here, and look at the output here. The first packet 172.16.1.9 is like my IP address. Destination is virtual server IP address. 172.16.1.201.201 is the virtual server IP address, and the first packet's in, and then immediately reset, right? Reset. It's not like a TCP SYN ACK and then reset, or maybe SYN ACK and then HTTP GET and then reset. No, SYN reset, SYN again reset, SYN then reset. Okay, because virtual server type is what? Performance layer 4, and in performance layer 4 means, let me clear this. Okay, performance layer 4 means TCP behavior would be packet by packet. What if I go with a different virtual server type here? Maybe another virtual server type, let's say performance HTTP virtual server, also used in like real environment. Performance HTTP virtual server, not the layer 4 performance HTTP virtual server. So basically it uses fast HTTP profile here, and performance HTTP virtual server is designed to speed up certain types of HTTP connections by combining features from the TCP and from this TCP, from even HTTP, one connect. Remember what is one connect? One connect means server side connections are reused. It's optimization feature, very good feature, right? And what we do, like we just associate, attach one connect profile with the virtual server. So it's very good optimization feature. Server side connections are reused. So basically in this performance HTTP virtual server, uh, like uh, like uh, features of TCP, HTTP, and one connect profiles, they all are combined into a single profile that is optimized for network performance, right? And what happens? What about the TCP connection setup then? What about the TCP connection setup if we create this performance HTTP virtual server, right? Performance HTTP virtual server. So here, now, a 5 big IP system establishes server-side flows by opening TCP connection to the pool member here, right? It's something like using the feature of one connect, in fact, just to avoid creating a server-side connection. So whenever client initiate connection to the performance HTTP virtual server here, and if LTM finds idle server-side connection flows, right? So it makes that non-idle and send client request over it. Means TCP SYN, ACK, and then HTTP request. Already there is a like connection setup with the server. Request is directed to that pool member, and flow is marked as non-idle from the idle. And what if there is no idle server, no idle server flows available? Then what happens? Then LTM chooses pool member and initiate TCP connection. So very different, like this performance HTTP virtual server TCP connection is very different because it uses uh, like combined feature of one connect TCP and HTTP profiles, right? So standard performance layer 4 performance HTTP virtual servers are common most virtual server type, and obviously you will find other virtual server type also, like the reject virtual server type, layer 2, even DHCP relay agent. Very rarely like they are used, not very common virtual server type, but yes, like there are different virtual server types here, but commonly used virtual server types are standard with layer 7, standard without layer 7, performance layer 4, performance HTTP, right? So I hope you understand like TCP connection behavior. And what if I just make at least one member in this pool enable? Let me show you that also here. Just anyone, let's say server 3. Yes, and was the status of virtual server green up? So as long like any member in the pool is up or enable or available, then obviously like pool status would be green here. And now I'm expecting a proper page here, and look at the output here. Yes, so the server IP address is 192.168.0.3, right? I access virtual server IP, and that's what like proxy is. So destination IP address is translated to backend server IP address. Destination IP address is automatically translated. You understand that because when we create virtual server objects, so by default destination IP address, destination port address translation, both are enabled. What is not enabled? Source IP address translation or source port address translation. Both are preserved, not changed, right? By default. If required, then yes, we can also enable that like source IP address translation, but by default source IP address is not translated. So proxy not always necessarily means the device will be using its own IP address to establish connection with the backend server, right? All right.